The Cluster 3A focuses on agricultural transformation and sustainability initiative. We are working on the agri-food supply chain, starting from the farm until the consumer. The aim is to introduce new technologies and new services that will allow farmers, the logistics sector, the agri-food industry, and the consumer to upscale the information that they have, whether it is on performing cultivation practices at the farm level, whether it is optimizing the route with regards to moving the primary production from the parcel to the industry, or the releasing this production, these processed products to the point of sale and providing the information to the consumer. Agriculture, like any other sector, is having pressures, whether those are regulatory or coming from the market. For example, the implementation of Green Deal is putting the reduction objectives in terms of input. On the other hand, we have the consumer requesting far more and more information with regards to where a product was cultivated, where it was processed, what is the environmental footprint, is it green, is it friendly to the environment. So within our cluster, we're focusing on delivering those services to improve the information along this chain. It is very important to check both aspects, both in terms of regulation, but also in terms of consumer demand. To do so, we use AI, robotic solutions, and digital services to support the farmers and guide them on every activity they perform. Let's say, for example, right now, farmers visit manually, or the agronomists visit manually each parcel, and they detect incidents or pest or weed infestations. Consider between the moment that a notice is taking place or inspection takes place until the notice that an action is being performed, there is a significant time frame that you might have significant losses into the farm. We aim to upscale this by using remote sensing data, drone data, robotics, AI, on one hand, to improve the efficacy, to reduce the time needed to inspect and perform an activity, and on the other hand, on the logistics and routing part, to make as much as possible to reduce redundancies and times between the right time of harvest, the right time of dispatching the harvesters, the right time of collection, and as quickest this primary production to move from the parcel to the industry, and then to move when it's ready from the industry to the point of sale with the minimum environmental footprint and the minimum spoil in terms of fresh fruits or vegetables. To make all those results tangible, we work on four main areas. The first is the parcel level. So we combine, as I mentioned earlier, drone data, satellite data, weather station data, IoT and weatherable plant sensors to monitor continuously the anti-nutrients in the vegetables. At the same time, we are fusing drone data with satellite data in order to have continuous monitoring per almost 3 to 5 days that is needed for having timely monitoring and timely intervention on the other hand. Once this information is being processed, then the direct tasking is moved to the ground robotics. The ground robotics either has already the information of a weed batch detection and moves to inspect in more detail this area, or performs the inspection of the parcel from starters. This means that any spraying activity, any crop protection product that is being applied precisely and on the right time. Then we have the logistics coordination. While we monitor with the use of satellite data and drone data the parcels, this means that we can alert both the industrial actor as well as potential outsourced or insourced logistics to know exactly when it is the right time of harvest and the priority that they shall deploy their harvesters to their fields. What does that mean? This means that we reduce a lot potential spoilage at the farm level, considering that the crop is being harvested towards its optimum time. At the same time, allowing for the raw production material to move to the industry at its best condition. This means that we allow the industrial sector to optimally process this, retain the nutrients to its best possible scenario, and also expect the incoming orders. Per each coming order, then the system recalculates the deployment of the new product, when it shall go, to which cargo it shall be loaded, and which route its truck shall follow in order to reach optimum time in delivery, but also with the optimum and lesser environmental footprint. All those services, devices, equipment, hardware, and so forth that we referenced earlier are not disconnected, are not, let's say, totally new interventions, but what they have in common is that up to date they have been partially used by different actors. So the main issue is the lack of interoperability or the fragmentation of available information. Copilot provides this infrastructure layer and orchestration layer that allows hassle-free and exchange of data among any type of equipment, any type of sensor that is connected and is working on top within this cluster. So what we can do is we use the blockchain, we use the hardware, we use the sensors without all the fuss that consider that you have to connect proprietary systems or systems that were previously not designed to interact. They have their own platforms. And now this orchestration layer allows not only those devices to connect and talk to each other, but also to make sure that data availability among the actors of the supply chain are only when requested and needed. So yes, we allow the data to flow throughout the chain, but we only allow, building on top of the Copilot infrastructure and orchestration layer, only the data that needed to cross between domains to be used. And consider that we don't have a low number of domains. We have 5 domains and 2 moving domains covering the routing and logistics. So it's a quite extensive number, both of domains and of devices that keep on communicating, integrating, and exchanging data in order for the cluster at its whole to provide the absolute best of services and the efficiencies as described earlier. Yeah, so far, all examples of all those solutions, hardware, IoT, and infrastructure deployed and being utilized is very successful. We have already seen some early measurements, and we compare those with the actual baselines. But further from the actual measurements, I need to highlight that we had also extensively positive feedback from the stakeholders involved, whether those are farmers, the partners coming from the agri-food industry, from the logistics, from the 3PL, even consumers association. So for us, further from having the, let's call it, the connectivity issues resolved, it is also equally important to see the perception of all those actors that are expected to somehow utilize all those data, but also the result of processed data. So all indications so far, whether it is tangible and non-tangible perceptions, are positively, and we expect to run an even larger pilot phase in the coming months to have even more concrete KPIs and measurements of every single domain, of every single service, and of every single improvement that we aim to deploy. Within this, again, extended pilot phase, our interest is to check also with internal partners, cluster partners, but also with stakeholders, and to improve this legacy of outputs. Let me go with some examples. In the farm level, considering the timely derivation, we have the comparison between a farmer and the drone and the robot inspecting the parcel and intervening timely. Only this can lead, the precision application can lead to 40 to 60% of decrease in cost, but also in a similar environmental footprint reduction. At the level of monitoring the farm, so far consider that a farmer or agronomist needs to visit one by one each parcel daily or every 2 days to have an idea. With the use of satellite data and drone images, they can remotely use, the agronomists can remotely provide, have an idea of the conditions of the parcel, and even guide farmers remotely without the requirement of daily or weekly inspections of the parcel. Now, when it comes to removing, let's say, inefficiencies along the supply chain, timely harvesting, timely moving, routing, dispatching of harvesters, and at the same time, the timely dispatching of the trucks, of the products to the final point of sale, we expect an equal improvement in environmental footprint and timely delivery that we hope that will reach almost 40 to 60% in environmental footprint reduction. But we need to check those figures, and we need to consider those figures collectively. We might have cases where we can surpass those numbers. We can have cases where those numbers will be marginally, let's say, lower. In all cases, aggregated, all those interventions are expected to have a far more greater result, and part of this result is supporting the other stakeholders around the other chains to also adopt those solutions. Not only the farmers that are participating within our pilots, but also neighborhood farmers or cooperatives that are around the area. All in all, we consider that both in terms of internal partners, stakeholders, but also the consumer's perception of, do I have enough information to judge about the cultivation, about the environmental friendliness, the greenness of the product, we perceive that we will bring a positive outcome towards the environment and the society in general.